Hi, so this is Patrick Chandati. I'm coming to you. It is December 14th, 2020, and I am making a quick presentation and demo of my VC funding app that I did as part of the UC Berkeley Data Analytics Bootcamp. And that completed on Halloween, so I'm just going through some of the older projects and making presentations, tutorials, demos. So anyway, what you can do is you can go to my website at patrickchandati.info and go down to the bottom and wait for this data science image to scroll along, and then has a bunch of highlights of the projects that I did as part of the UC Berkeley Data Analytics Bootcamp. So I've got about 8, 10. Anyway, you're going to scroll down close to the bottom and you're going to look at this data dashboard thumbnail that has a few different green marker circles on it. It shows a map of the United States. So if you click on that picture, it will bring you to the app itself. And it is listed as Frozen Dawn 61622 HerokuApp.com. So to start going through the presentation, we did prepare a presentation for this, me and my teammate Kanishka Ramanan. So it is just a good way of providing some structure to this kind of demo and some background information that you might not otherwise get. So anyways, the project is VC funding worldwide between 2005 and 2015, and it is a data visualization dashboard that is available on Heroku. The deployed app is available at this URL. So to continue, why did we do this project? We were looking at different data on Kaggle, which is a data science website that helps, I think you can actually get trained on it. You can learn how to use different data science, become a data scientist, use different data science tools. Kaggle itself is available here. It's got my information because I have an account on it, but otherwise it would have your information, or it would just bring you to a page, like a home page. Anyway, we wanted to get some data from that to try to do a project that would be useful, especially considering that we're students, kind of upskilling in my case as a software developer. So learning more about kind of VC funding startups seems to be a really relevant topic to someone looking for a position as a software developer or data scientist or data analyst, just someone working in kind of the tech sector. So anyway, this data set kind of looked useful to problems we might see or just different information we might actually encounter in the world. So some of the questions we had about like what we could learn from it or what it could kind of explain to us would be, what are some major startup hubs around the world? We figure if we find kind of concentrations of startup hubs, that there's likely an overlap with a lot of the kind of established tech companies as well, so that there's likely a presence of large tech firms or that has a developed technology industry in that location, because a lot of the times startups are kind of an expansion or spillover of the same kinds of software developers or tech people that are now starting their own companies and getting funding from places like venture capital firms. So that was kind of our hypothesis, that by looking at startup hubs, you could also kind of find places that might be a good place to work as a software developer. So is there a large international presence of startup funding? So is most of the funding in the United States, or most of the startups in the United States? Beyond the United States, how else is the funding or startups, how are they distributed throughout the world? Are there some countries that have a lot of startups or funding, and maybe why. So we also looked at what could contribute to a startup being successful versus failing. Because this data set did have a lot of information on the different funding rounds. So it went down the funding rounds A, B, C, and it went pretty far down to like L or something. I don't really remember at this point, but it does have 39 columns, so we can go look at that data set in a minute. But anyway, it's got a lot of information about the different funding for the startups, and then it also has a column that says if the company is bought, so acquired, active, or inactive. So we were looking at maybe trying to look at some of that information to see if we could predict whether a startup is still active or not based on other information, which is like a machine learning project. But for the purposes of this project, kind of the scope didn't involve making a machine learning model to determine whether startups would still be active or not given different like funding variables or location variables. So we were also looking at kind of the top 10 cities in the world by the number of startups, by kind of how much funding each startup got on average, and then by how much funding kind of went into that city for all the startups there. We were also looking at what percentage of startups are found where in the world, and then also how the percentage of overall of funding per location compared to like 100% funding for the whole world. So it's almost like a market share of count and funding for startups for different cities, and then as you change the map, which is kind of one of the key features that's really useful for this map, that I'll explain it when we get back into the maps themselves and look at them. But looking at that, there's a way to kind of group them together so you can see how different areas kind of become more relevant for startups or have a lot more startup activity. So, which actually wind up being places like Silicon Valley. So to continue, we got the data from Kaggle, so I showed you that already. The data on Kaggle is from Crunchbase. So if you go here and you look at this little summary of the project, explanation of the project, you can get the data here. It says Startup Investments Crunchbase. So it's a usability 8.8. It's about 12 megabytes, so you can get that CSV, comma separated value file right there. Like I said, 39 columns, so it's a really wide data set. I think it only has like 70,000 entries, but then we cleaned it and it actually wound up being fewer than that, I think 50,000 or so. Anyway, we had to also use the Google Maps geocoding API to try to get the location, the latitude and longitude of the different cities throughout the world, because we were given information for cities, states, countries, but not necessarily their latitude and longitude. So we had to go in and get the locations, the coordinates for each of those cities using, actually built a Jupyter notebook that kind of pings the geocoding API and gets that information for us so that we can put the markers on the map in the right spots. And then we put the data into Postgres using SQL, Alchemy, and Pandas because it is a Flask app. So if you go back to the app itself, this is a Flask app, uses Python and Flask and SQL Alchemy. So SQL Alchemy goes in and queries the database, and it actually puts the data, you can put the data there, but we mostly used it to get the information from the database. So this Heroku app actually does have a SQL container because they have different ways to do it with Heroku, just the way they deploy it. So it's got like the free SQL container. And Pandas was used to clean the data and load it. And then we made some visualizations, and I'll get into those more in a minute, but there were two different geographic map visualizations that used Mapbox and then Leaflet on top of the Mapbox. And that's we have a cluster map and a chloropleth. And then we did 4 bar chart finding visualizations that uses the chart.js framework. And then we have 2 RESTful APIs. So we would have to refine the APIs at some point if we were making this kind of scaled. But right now there is the entire kind of database given via one of the API endpoints to load into the map data for the visualizations for the map. And then we made it so that you could get each city, information for each city from the API. So you only need the city names and country codes to get a single city's information. And then it is on Heroku, like I said. So it's a single page full stack app. It is one page. It has a menu, and then it's pretty simple, straightforward. It's click, point and click, use the mouse for everything. You can drag the maps to change them around. You can use the mouse wheel to zoom in or out. I'll explain, kind of do a demo of how to use the maps themselves, how to navigate on them and get to them. But Heroku means that it's publicly available all over the internet. You could get on it with a phone or an iPad. I wouldn't suggest a phone, but it would work with a phone. But an iPad it actually looks good on. It's got pretty easy controls, like I said, just a mouse. It loads pretty quickly considering how much data there is. It only takes a couple seconds. And then what we were looking at doing eventually, if we kind of got more funding to kind of make the app more production ready, almost like a service, would be to get dynamic links from the Flask app on Heroku to live update, so that whenever new data is posted on Crunchbase, it would actually we could actually update the data like every day, and it would add the new data to the database, and then it would change how the visualizations looked. So it would change how the maps and then the bar charts looked. But we aren't at that point, mostly because the Crunchbase API, you'd have to use a more advanced Crunchbase API. You can't get that data without paying. And then you have to pay kind of a lot to get it. They don't say how much, but they have to go and you have to fill out an application. They have to note that you're a legitimate company, that you have a legitimate project and use for this information. And then they have to go in and look at that. So like case by case. And then I think someone was saying they looked into that when we presented it somewhere, and they said maybe it's $10,000 a month. So it's also probably expensive because it's a company, like the company has to actually pay for that account and actually exist for that account to be at that level, the kind of like Pro Plus or whatever API, and it has to be approved by them. So anyway, we did start with the cluster map. It has 5 different layers of markers that show different data. So the first layer shows startup count by city. So we can go to the app right now. You click on maps and then cluster map. It takes a second to load, and then you can see that there are numbers and colors and circles, and then as you zoom in, they kind of spread out, and if you zoom out, they kind of group together. So that's what a cluster map is. So this like 1060 represents a cluster that is most of Los Angeles, it looks like. But if you zoom in, kind of breaks down into composite parts of Los Angeles. And then how many startups are there, given the city name from our data. So on a blue, pin is just 1. So you can keep zooming out. You can go up the coast. See, it looks like a lot are along the coast, not as many maybe inland in California. You can keep kind of zooming out. But so anyway, if you zoom out all the way, you can see kind of huge regions. So like this is China and like northern India, and then kind of southern Asia, I guess, Southeast Asia. And then you can see like, oh, this is Alaska. Oh, this is Hawaii, or whatever. This is like most of South America. If you zoom in, and it's like, oh, it's mostly, not as many maybe in Brazil as compared to like Chile, whatever. Anyway, you can kind of look at that on your own. It's a lot of information, just number of startups, so like this counts pretty high. And then the colors, yellow is anything less than 100, more than 10 or more. Green is less than 10, and then orange is anything more than about 100. So anyway, back to the presentation, you can look at the startup count by city, and then zoom out and it'll kind of group them together. You can look at the total funding amount by city. So if we go back to the map, and you use this icon, it's kind of not that straightforward, easily kind of used or straightforward if you didn't know that, just the way that leaflet and Mapbox work. But you can change to this different layer, and we'll do, I think we did, what was it? Total value. Yeah, so total funding. So we go to the total value, and that's the funding. So this one uses different markers. You can see down here, bottom right corner, you can see the legend, and it gives you the order of magnitude of each of the different markers, how much funding there is. So each color is, each shade that's one color, like one shade darker from yellow to red, actually turns out to be an order of magnitude. So it's 10 times more money that goes there. So if you can see yellow, this is like 4.8 times 10 to the 5. So 10 to the 5 isn't that much. 10 to the 5 is about $10,000. So that's like $448,000. But then if you look at like a really kind of heavy like startup area where there's a lot of funding and a lot of startups, like the West Coast kind of, or it's not the full West Coast, but if you go into like California, this kind of region that's highlighted, it's about 2 times 10 to the 11th. So if we look at this chart, that's $200 billion dollars of funding going right into this kind of region. So it shows kind of southwest United States, but it also includes kind of San Francisco, Nevada, as well. So you can zoom in on this map too, and the markers will break apart. So California, if you go back, it shows this region, and then you zoom in, and it breaks them apart. So you can see kind of northern California by San Francisco, Silicon Valley. You can see Southern California kind of by LA, San Diego grouped together. So this one, for example, it's hard to tell the shade on kind of the darker ones, but this is like 5.6, so 56 billion, and then 140 billion. So you can see, and this is over the full 10-year period, 2005 through 2015. So we didn't break it down to year-by-year data, but we would look at doing that at some point. And you can see another big spot is the Northeast, New York City, which has about 100 100 billion, 109, 110 billion. So you can see kind of where the money is going and how much, especially if you notice that the colors are more orders of magnitude. So if it's a shade lighter, then it's like closer to yellow, then it's actually a lot less money. It's about 10 times less money that can be represented by that marker. So we had to use that kind of just logarithmic scale because it actually wound up being such a difference in value from 48,000 to 200 billion. It's hard to represent that on the map with like different shades and then having the colors mean something, because if you did it linearly it wouldn't really work, because there wouldn't be enough levels differentiating them and it wouldn't make that much sense. So anyway, that is the next layer. Third layer is average funding amount by city. So we had to do kind of the same thing, startup average value. It has the same kind of legend, so it goes from 10,000 to 100 million. Average value of the startups per kind of area, so you can see it kind of group things together again. Just the different markers, areas, and then if you zoom in, it splits them apart again. So again, if you look at like California, for example, it shows 2.2, so 22 million is what kind of the average startup would be worth, what the average funding would be for Northern California, and then about 16, 17 million for kind of Southern California area. If you were looking, or like if you want to look at New York, you can see about 24 million for this kind of area. So, and you can see like it's like a lot less here or whatever. For example, this is 10 to the 5, so it's 670,000 right in there. So what the average startup's worth, or funding is worth, how much they gave it essentially. So you can look at that more when you want. Also has the percentage of startups in one city versus all the cities, and it also groups just like it did for these maps. So if we go down, it's got the percentage startups, and it actually instead of doing colors, we did marker sizes. So those marker sizes are proportionate. They all add up to kind of the same size overall for the whole world. And you can see the overall, this one is startup count. So where the startups actually are within the world, and the smaller dots are fewer startups, and then bigger dots are more, just number of startups they count. And then it shows the percentage of all the startups worldwide. So you can see this area has kind of like 28% of the startups, but China only has like 2.7%. Eastern China, I guess, according to this data, 2005 through 2015. We'll get into more of the maybe kind of issues with the data later, but you can see like United Kingdom has a lot, kind of Seattle has a lot, Portland, kind of Central Europe. Anyway, you can zoom out as far as you want, just about, and then if you zoom in, you can look at like the United States, and this was actually the thumbnail for the website link that we had on my website on the portfolio page for data science projects. So you can see like up here, what I like looking at is if you look at this, it's got San Francisco and then kind of Mid-Peninsula and then San Jose, and you can see kind of how the different areas break down, and then you can keep zooming in farther till you see different towns and cities. So San Francisco still stays pretty big because it's got a lot of startups, but then you can see it kind of spread out to the different towns. So like Mountain View, it's like where Google, Facebook, all these headquarters are. Anyway, it goes down to individual cities. That's kind of the granularity of the map. The finest level is one city. So anyway, then we have percentage of total funding in one city versus total startup funding worldwide. So if we go to the last layer that we have here, we've got, this one's kind of similar because it's kind of like the average startup funding times the count. So this is going to be how much funding out of 100% of the funding in the world goes to this location or this area that's kind of covered by the marker. This is like an anomaly. It does say 14.6, but that isn't 100% accurate because I don't think they have that much funding there. But I haven't looked at the data itself. That is Bermuda. So, but maybe they have special laws there that mean that it makes sense to headquarter a company there. But so this is still kind of a new feature. The values are approximate. It's a good way of showing kind of relatively how much money goes where, because it's all percentages and marker sizes. So you can see like the United States map, it shows kind of the same thing with funding, like good amount in Northern California, Southern California, New York, kind of DC, Chicago, what's this, Texas, it's got kind of Dallas, Austin, kind of Texas area, and then like a Seattle, kind of Portland, Oregon area. So kind of where startups are in the United States, where they get funding. And then how much funding they get, you can go back to the other startup total value and you can see like the numbers. But it won't give you that same kind of sense of relatively how much money goes where. From the source we had, which was Crunchbase. And this might be an issue. This might be kind of an error. I'll have to look at that later, but Bermuda seems kind of high. Anyway, going back here, so that was a cluster map. That was the first of the two maps with the different layers. That is the cluster map of the United States with the count, company count per kind of cluster. So that was the first layer that we looked at, the top layer. With the Core Plus, we can go in and see there are 3 different layers of information available. We'll go into that number of startups per country, but you'll see the US, so we can go look at that right now actually. So you just click on Core Plus, and a Core Plus is like a shaded map. So the shading represents some value, and then the different areas that are shaded are geopolitical boundaries, so like the different nations, countries. So here you can see the company count, and it gives you a legend, but it doesn't really make sense because this is like linear data, but it turns out if you click on this, it's got 24,249, so that's the highest number. And then if you click on any other country, it's going to be fewer than 6,000 startups actually. So I think England was the next, and it's got almost 2,100. Or Canada, which is the one after that, it's got almost 1,200. So it just kind of becomes, the America has 24,000 plus, and then the next biggest country, as we'll see on the next map, has about 2,100. So it's an order of magnitude. It's got about 10 times as many startups in the United States as anywhere else, according to this data for 2005 through 2015. And then we can see number of startups per country excluding the US. So what we had to do with this next map, this next layer, is remove the United States from the data set and look at all the other countries and see if we can find some kind of distinctions between them so that they're not all just this kind of lowest level. So we went to kind of a second tier. So America, United States first tier, great. And then if you go down a level, kind of excluding that, what are the countries that kind of stand out in terms of company count? And you see England, United Kingdom is there with about 2,100, and Canada with about almost 1,200, or I'm sorry, 2,100 United Kingdom, almost 1,200 for Canada. Then you can see France has 713, China has 841, so then China, France, India has 639, which was fewer than France in this case. Germany has 617, Spain has 455, this country, it's France, apparently. Anyway, you can see, kind of looks like China, India, what's this? Yeah, India, and then France. So kind of looks like Western Europe, mostly Canada, China, India, kind of have a lot of startups. And then the third thing we looked at was average funding for startups in each country. So just to get a sense of kind of how much each startup is worth or funded at for each country. So this map had 3 different levels. We found it broke that we kind of grouped them into 3 groups. No startups, which are white, so there's no funding there. Then there's like a kind of moderate, there are startups that are worth something, but not the most that we looked at. So that startup's worth up to about 8.4 million. And then anything worth more than 8.4 million, average startups being worth more than 8.4 million are given as kind of the darkest level of country. So you can kind of look at that and see that like the India and China startups are worth more on average than like France or Spain, even though France and Spain had a lot of startups. So it's just another layer that you can look at. So you can see exactly what I explained, US dominance, different funding levels for each country, and then this is what a zoom in of Europe looks like for the company count for second tier. So it shows the United Kingdom as having the second most startups, but most in this map because we exclude the United States. And then if you go to the VC funding bar charts, which is the next part of the app, so here you can see this is maps drop down. We have visualizations, so these will be bar charts. So we have an array of the top cities. At some point we update that so that it's not just an array, that it like gets the information and then determines what the top cities are, especially if it's dynamically live updating. But for the purpose of this kind of data app, we didn't need to change the information, especially since it's static data that it doesn't change because it ended in 2015. So it works for this particular case. We looked at America and got the top 5 American cities versus the top 5 foreign cities because America was heavily dominant with this data set in terms of total funding. And then we also looked at the funding by the different types of funding, so the different rounds, and then different types of funding like debt, equity, or venture capital. So, and this uses charts.js. So you can see some examples here, but these are in the presentation, it makes more sense to go to the app itself, and you can go to total funding. So this is how we identify the top 10 cities kind of worldwide, or United States and not United States foreign. So here you can see kind of the more complete data where it's got the different types of funding represented at the top. So seed, angel, venture, round A, B, through F, private equity, or debt. I don't have a startup and I don't really know the different rounds and kind of the distinctions between them. But that might be useful to someone. So you can see here, especially with New York, the kind of biggest finding was that New York has a lot of debt. The largest kind of source of equity out of all these sources, funding, was the debt. So they take out loans, it appears, in New York City. But if you look at like the other cities, San Francisco, Palo Alto, San Diego, Cambridge, Massachusetts, you can see that these debt values are much lower than this value that kind of stands out on all of them, and I think that's venture. So venture is kind of the highest amount, the largest funding round other than New York City for the United States, and then that is also true outside the United States. So you can see the debt rounds, debt, isn't even debt, and then you can see the venture round that kind of stands out much more than that. And it looked like Moscow actually, private equity was more than the venture round, but everywhere else it looked like it was venture, or the source of the funding. So that is for the total funding for all the startups that we have information about there. And then if we go down to average funding, we can look at the US and see that almost half the funding in New York City was debt funding. So there's the average equity funding and average debt funding, and that almost 50% of all the funding was debt for New York City startups. But everywhere else it's pretty imbalanced and weighted towards equity funding versus debt funding. And if you look outside the United States, you can see kind of these developing countries like China, which have Beijing and Shanghai, and then India, Bangalore, that the average funding for the startups are more, that they get more funding per startup. And then we also have London and Moscow. So looking at, let's see. So we did have to mention some possible issues with the data set. It is old data because it's free. It's on Kaggle. It might have some issues with accuracy that are just typos when the data was input, because I was trying to find Albert, Germany, when I was trying to find the coordinates of each city, and we actually found out that there is no city Albert, Germany. So I went on the company website and it was actually in Alberta, Canada, a different whole continent. So there might just be some misspellings or typos or misentries with the data that could cause some slight issues, but the general trend should still be overall correct, because most of the data is accurate in terms of being valid, that it's from Crunchbase. Most of it would be entered correctly, and then the general trends would still stay mostly the same in terms of, like, especially the kind of percentage funding worldwide or percentage number of startups worldwide. That would be pretty close to the same. Again, the data is older, so we didn't break it down year by year. You could see how the funding works for different years, which would be interesting. That would be a good next step, especially looking at the recession economy versus the pre-recession for about 2008, 2009. So see if funding kind of drops off a cliff after 2008. or if there were just kind of, yeah, just if there aren't as many startups getting funding, or kind of see how it shrinks for those years. And then showing like information with date filters, so you could show like a date range, or you could show 1 year. And then additionally, the data might be incomplete, because this is kind of a United States centric data set. Since it does have the fundings in United States dollars, I think most of the startups were in the US, Great Britain, and Canada, especially the United States. And the data is from Crunchbase, and I think that's an American company. So there might be sort of information that isn't getting entered into this database on Crunchbase, like foreign startups or funding sources that aren't known. And that would be especially true with places like China or Russia, that may be, especially now, there's like a bill where they're looking at delisting some Chinese companies from the stock exchange because they don't release their accounting data. So it's just like they report numbers, but they don't show the actual kind of books they use to get those numbers, and they don't release that information. And some of them do, some of them don't. So people think that they're kind of inflating the numbers. So in this case, it could be that there are like smaller startups that get internal funding, and then maybe if they get to a certain level, especially given the data back here, where it shows the average funding being higher for kind of China, that it would show that maybe once they grow to a certain size, they need to get foreign funding, or they can start looking for foreign funding. So there might be a lot of smaller startups in China or Russia or different countries that we don't maybe know as much about, because they don't try to get funding from the United States. They also have web censorship, so we don't know. It's kind of hard to get accurate information from some of those countries. Then questions, and then we have libraries used. So we used, for data cleaning, scraping, and SQL loading, we had pandas, request, JSON, and PyCountry. That was to turn country codes into country names, or vice versa. The dashboard app has Postgres and SQL Alchemy. And Flask and OS. OS library. These also have jQuery, Time, Gmaps, OS, SQL Alchemy. Gmaps was used to plot the data. So just in the notebook, you can plot the data using Gmaps. So it's like a quick way of checking the work. And then dashboard app has Chroma.js for some of the different colors for the legend. Chloroplet.js, which was like an add-on kind of to Leaflet. Leaflet is an add-on to Mapbox that makes it easier to kind of use and manipulate and make kind of fancier charts. And then just some more country code conversions. Chart.js, which is Chart.js was actually used to make these bar charts. So these are like the standard Chart.js bar charts. And then if you go back to my website, it has other data science apps listed, but really what we'd want to look at is that the code is available here, and you can see that it's got a README. So it would be good to go through this README if you wanted kind of more detailed information. I still do need to complete some sections, like the choropleth details and explanations, but actually this is kind of the whole app. And then like let's do an example of like a finding. So one thing that like we could find with the data set is we were seeing okay, with the chloropleth, we were looking at it and it shows United States. And then after the United States, it shows Canada and UK. But then if we go to, it shows almost 1,200 companies in Canada. So if we go back to the cluster map, we look at this and we're like, oh, I wonder where they are in Canada. So it shows this map and it shows, oh, it looks like maybe 1, 5, 6, 7, 141-ish in Canada. So they're like, so it's just like, oh, how is there 141 that we can see, but then how are there that many actually in Canada, 1,200? So what I found out for this particular example is if you look at, you have to zoom into the border, and you can see there are all these Canadian cities across the border. And right across the border, they have kind of concentrations of startups. So, for example, here we have, I think that says Montreal. So Montreal, but if you zoom out, it shows it kind of grouped into this kind of Great Lakes area. Or here you have Toronto, which is grouped into like the Great Lakes, which also looks like America, like the United States. Because you do this, if you zoom in, it shows like, oh, it includes it, but it's hard to tell. And then here, the Northwest, you can look at, and it shows Vancouver versus Seattle, but it doesn't, it moves them based on kind of the weights. So it moves, like if there are more in Seattle versus Vancouver, it'll move the dot towards Seattle, so it looks like it's all Seattle, but in fact, about a quarter of it is Vancouver. So that's a good way of looking at kind of how you can find some different sorts of information by kind of examining the different maps and seeing different kind of trends or anomalies or different features that seem like they wouldn't make sense or they do, or like where the funding is. So it's not like it's in, Saskatchewan. There's not a whole lot in Saskatchewan, that province, or Manitoba. There's not a whole lot. So especially, so it's not so much out here in kind of the wilderness. It's more kind of by bigger cities that are on the border. So that's like an example of something you could find out just by looking at a couple of different maps and trying to like reason through or click through why they look the way they do. So anyway, going back to my website, I encourage you to check out some of the other projects I have here. I did do a presentation demo for this, the USGS data dashboard, and I will upload that to this website so that you can look it up at some point. But right now we have data dashboard, and I'll go through some of these other apps and try to walk through demos for them as well. So I also encourage you to visit my website because it gets updated pretty frequently. Let's see, what's some new stuff that's been on here. This whole data science kind of page is new. So these are all just about all from the UC Berkeley Data Analytics Camp. So I encourage you to go and check it out if you have time.